Okay, first of all, thank you for the opportunity. My name is Keith Chapman, and I work in the Security Operations Center as a senior cybersecurity analyst. I lead the threat intelligence efforts on our team, and I've been in cybersecurity for over 5 years. I have EC Council's Certified Threat Intelligence Analyst certification, and I've been exploring ways to be more proactive in defense and detection. These are some of the ideas. My goal with this talk is to share a method of getting more context from threat feeds and to use them in a way that enriches what's important to you. Previously, we imported unfiltered threat feeds into our SIM environment, and it was a big time waster. So I proposed a targeted approach. I created a heat map that gave priority to the top advanced persistent threat groups that target our industry. This allowed us to create weighted intelligence feeds of high value, such as tactics, techniques, and procedures that align with the MITRE ATT&CK tags. The indicators of compromise that were provided enriched alert data and produced far fewer false positives, at times more than 600%. Disclaimer, this is a reference design, and I've made changes so that Belkin's security stack is obfuscated. Imagine this idea like a pizza. What am I defending? Like a pizza, the ingredients that you want can be custom selected. A layered intelligence is built for the purpose of defense. Working together, the whole is greater than the parts. So some of the parts that we used were environmental intelligence that connected all the other intelligences together, curated threat feeds, global and community that enriched detection, and proactive intelligence that gave a targeted and actionable defense. So what is an advanced persistent threat? An APT, or advanced persistent threat, is a stealthy computer network threat actor, typically a nation state or state-sponsored group, which gains unauthorized access to a computer network and remains undetected for an extended period. Such threat actors' motivations are typically political or economic. It may also refer to a non-state sponsored group conducting a large-scale targeted intrusions for specific goals. And every major business sector has recorded instances of attacks by advanced actors with specific goals seeking to steal, spy, or disrupt. The median dwell time, the time that an APT attack goes undetected, differs widely between regions. FireEye reports that the mean dwell time for 2018 in Americas is 71 days. These are some of the groups that we looked at: APT 18, APT 38, Deep Panda, APT 41, and Fancy Bear. I like this naming convention. This is the one that CrowdStrike uses. They use Spider for e-crime, Kalima for North Korea, Jackal for hacktivists, Tiger for India, Kitten for Iran, Leopard for Pakistan, Panda for People's Republic of China, Bear for Russian Federation, Crane, South Korea, Buffalo, Vietnam. So what is attack? MITRE ATT&CK is a knowledge space of adversary tactics and techniques based on real-world observations. Tactics are what attackers are trying to achieve, and a technique is a specific behavior to achieve a goal. It's often a single step and a string of activities. This can be utilized as a foundation for development of specific threat models and methodologies to detect and defend against cyber adversaries. And the attack website provides many details about each technique, including description, examples, references, and suggestions for mitigation or detection. These are the techniques that the APT-19 group is known to employ. Techniques and tactics tend to be slow to change and relatively stable. So APT-19 is a Chinese-based threat group, and they've targeted defense, finance, energy, pharmaceutical, telecommunications, high tech, education, manufacturing, legal services. MITRE provides background on all the threat actors. It lists associated groups, typical target industries, and other descriptors. They also go by Kadoso, Kadosu, Kadoso Team, and Sunshot Group. This is a partial list of techniques that this APT group uses. And this is a detailed description of the drive-by compromise technique that they're known to deploy. This is when an adversary may gain access to a system through a user visiting a website. It could be a legitimate website that's compromised. It could be malicious ads that are served through a legitimate ad provider. And it could be a built-in web application for something like forum posts or comments or other user-controllable web content. Often the website used by the adversary is one visited by a specific community, such as government, particular industry, or region. And the goal is to compromise a specific user or set of users based on a shared interest. This kind of targeted attack is also referred to as a watering hole attack. These are mitigations that can be used to stop this technique. Techniques are not inherently malicious, but can be used by bad actors. Many are normal processes or actions. You can restrict web-based content. You can keep your software up to date. You can use application isolation and sandboxing. Finally, MITRE also provides guidance in how malicious application of a technique might be detected. I'll be revisiting this later. With this technique, firewalls and proxies or NID systems can be used to detect. So the first step was to select the APT groups that target your industry. I chose financial, defense, non-governmental organizations, healthcare, education, aviation, energy, retail, and technology to do a proof of concept. This Excel spreadsheet shows what APT groups are targeting each sector. This chart shows a number of APT groups targeting each industry. Financial and defense are the two most heavily targeted in my research. This was the initial visualization that I made. This highlights the techniques of APT groups that target defense. MITRE makes it very easy to visualize this data. This process is time-consuming, and I would recommend working on a technique at a time and documenting as you go. So this is a process that I used. I'll go into more detail about this later. Identifying APT actions at this portion of the chart gives you the biggest win. Groups stopped at this stage haven't been able to maintain persistence or exfiltrate data. The darker the color is on the chart, the more APT groups employ the technique. The next few slides show how different techniques are used for different industries. What drove this idea is that I wanted to focus in on the potential threats that can make the most impact on our industry. We are a smaller team and we have to maximize our resources. What aviation faces is very different than APT groups targeting retail. This chart also highlights sub-techniques. MITRE has released sub-techniques in beta form to provide more ways to identify bad actors. These are the techniques of APT groups targeting healthcare. These visualizations are useful in communicating the risk of controls to others in your organization. And now that you have all of this, you can use a threat intelligence platform to create custom prioritized threat feeds. This weekend, other presenters have demonstrated how these techniques can be detected and tested. Please check out the other threat intelligence talks. Retail and healthcare have more overlaps. For both industries, initially compromising valid accounts is the most likely attack vector that could be employed by APT groups. So a valid account attack. This is when adversaries may obtain and abuse credentials of existing accounts as a means of gaining initial access, persistence, privilege escalation, or defense evasion. The adversaries may choose not to use malware or tools of conjunction with a legitimate access to make it harder to detect their presence. The overlap of permissions for local domain and cloud accounts across a network of systems is a concern because the adversary may be able to pivot across accounts to reach a high level of access. And these mitigations are for this particular type of attack: password policies, privileged access management, or application developer guidance. So what happens if you find these IOCs in your environment? You can share with others. This is where the threat intelligence platform is key. What is a threat intelligence platform? It can also be abbreviated TIP. It facilitates the collection of aggregation, correlation of threat data from multiple sources in real time. This helps analysts identify threats that are relevant to the organization. Traditionally, sharing threat data is a manual process, either through email, spreadsheets, or a ticketing portal. This approach does not scale. However, the use of APIs or APIs allow for the automation of actions without the direct user involvement. A tip makes it easier to share threat intelligence with other stakeholders, and the data that's collected can be used to enrich and contextualize other alerts in security stack. Tips use APIs to generate who is information, reverse IP lookup, name servers, domain block lists, etc. The tip automatically analyzes the context of threat indicators to identify threat actors, tactics, techniques, and procedures, TTPs. Let's take a look at MISP. MISP is the malware information sharing platform and threat sharing. It's a threat intelligence platform for sharing, storing, and correlating indicators of compromise of targeted attacks, threat intelligence, financial fraud information, vulnerability information, or even counterterrorism information. When you first log into MISP, the events page is the default page. Events are tagged and sortable by clusters. You can filter events by clicking on the tag of interest. In this example, we're using the APT tag. After finding the APT tag, events can be further filtered or viewed in detail. Related events, attributes, and sightings are linked to each event. Correlation graphs can be displayed for each event as well. You can search tags. The search returned events that include MITRE ATT&CK T1193, which is spear phishing attachment. This event was submitted by ESET, and a white paper detailing the Operation Ghost Attack was included in the feed and can be downloaded for review. Each event can be exported in a variety of formats, including CSV, STIX, JSON, or as rules for IDS solutions such as Stort or Suricata. This event includes additional MITRE attack tags besides T1193 and can give a security analyst additional indicators of compromise to be aware of. It also included a white paper that can be downloaded to learn more about supply chain attacks, including detection methods and mitigations. MISP can be used to handle threat intelligence from a variety of sources, not just threat feeds. Threat intelligence information can be shared from ISACs, email, or manual updates. These targeted MISP feeds can be automated to enrich other security tools in your enterprise with the curl command. The automation component is built directly into MISP. It walks you through step by step of how you set it up. Using a REST client and the query builder, custom feeds can be generated and shared. This curl script will automate the publishing of a feed that includes the APT tag. This can be run on your SIEM or data lake. And this is a sample output of the APT export. This is fed into Elastic and can be pushed out to firewalls or AV or other security tools. It can update as needed. So how can this be scaled? And how does it fit into an existing environment? This is one way. This is still a work in progress. It's been tested in the lab, a non-production environment, and we are feeding Elastic atomic or target indicators for the purposes of enrichment. We're seeking to make this information collaborative, and our goal is to get more context from threat feeds and to use them in a way that enriches what's important to you. So it starts off with collecting your log sources, feeding into Elasticsearch and Logstash. They can be visualized in Kibana. The Hive, Cortex, and MISP work together to enrich and to manage cases and analyze observables. And Sigma can be used to allow you to share signatures in a non-vendor format, which you can collaborate with the community. This is one slice of the cybersecurity pizza that I showed you at the beginning of the presentation. This is an exploration of fusion analysis, taking intelligence from multiple sources and bringing them together to create something greater. So with environmental intelligence, we're looking for high-value log sources that are chosen for their visibility and relevance to use cases. Machine learning can be leveraged to produce alerts based on anomalous behavior. So the idea is that you leverage your systems to give you visibility of what's important to you. In this model, we're most concerned with log sources that best reveal APT activity. Curated intelligence. This community shared intelligence that's collected and curated to enrich the security stack with leading indicators of compromise to give added context to attacks. With the Hive, it manages cases, it can be used for threat hunting, investigations, and it has custom Python modules that can be utilized as well. This chart shows how MISP can be positioned within your environment from a high level. The ingested feeds are being sorted by tags related to APT groups. MISP is integrated with the Cortex and Hive for enrichment and case management. Signatures are rewritten with Sigma so they can be shared with ISACs and other teams in a vendor-neutral manner. The last component is proactive intelligence. This counterintelligence is real-time. Active defense makes attacks more difficult for attackers. And this one, we're using Think's canary tokens, and they can emulate any of these items. We don't have to emulate entire systems. We can emulate just a email address or a document that would give us the most context of all, because it shows what attackers are actually doing in your environment. By using active defense and cyber deception, we're trying to slow them down while learning as much as we can about them safely. If you're not using a tip, MISS, the malware information sharing platform and threat sharing, is a great place to start. Use it in combination with MITRE ATT&CK framework. There are great communities for both, and they are widely adopted. So in conclusion, I would say research your industry, make a heat map, and consider each technique. These are all the steps that I took to create the targeted threat feeds. And I will make the slides available after the presentation. And again, this is what it looks like all together. My slides will be available at this GitHub, or you can contact me if you have any questions or if you have ideas of how to make the workflow better. Thank you for your time.